Hello everyone, in this video let us solve some problems of exercise 1 from Sadiko textbook. So these are the questions here. Here they have asked to find out how many coulombs are represented by these amount of electrons. So they have given the number of electrons, you have to find the number of coulombs. So now you know 1 coulomb, 1 electron has 1.62 or 602 into 10 raised to minus 19 coulomb charge, negative charge. Electrons have negative charge, protons have positive charge, neutrons are electrically neutral. So 1 coulomb we know it is 6.25 into 10 raised to 18 electrons. Okay, but for us this matters here because 1 electron has this many coulombs, then these many electrons will have how many coulombs. So it is nothing but if this I am multiplying this with some value, I have to multiply the right hand side also with the same value, right? So if I'm multiplying this with 6.482 into 10 raised to 17, then this also should be multiplied with the same number. That means in all the problems the right hand side one part will be common, that will be the number which is written, okay, that is given in the question, and everything should be multiplied with the charge of 1 electron. Okay, charge of 1 electron. So after simplifying this, you will be getting the answer in negative because it is in the coulomb means electrons will be having negative charge. So 10 raised to minus 19, 10 raised to 17, first solve these two. Okay, then you can use a calculator and you can multiply these two values and write down the answers here. Okay, so next, determine the current flowing through an element if the charge flow is given by. You know the current is the rate of change of charge. Rate of change of charge. So this is the formula for current. So now I have to find the current. This is given. So you know Q is a function of time, means it is dependent on time. So that's why I have taken Q of t and I am differentiating it with respect to t. So now this is also we can see t terms here in the right hand side. So in the first question, differentiate this with respect to t. So d by dt of 3t plus 8. Coulomb will become ampere, so milliampere. So differentiation of 3t is 3. Differentiation of constant is 0. So 3 milliampere is the answer. Likewise, you can take here d by dt of 8t squared plus 4t minus 2. So differentiation of this is 8 into 2t plus 4 minus 0. So 16t plus 4 ampere. Because it is coulomb, it is ampere. It is millicoulomb, it is milliampere. Next, it is nanocoulomb, it will be nanoampere. So next, I am taking 20 e to the power of minus 40 cos 50. So here I am following the chain rule. D by dt, 20 is constant, so I am putting it outside. E to the power of minus 40 cos 50t. So first I will keep this constant and I will differentiate this with respect to t. So minus sine 50t, and you know t has coefficient 50, so it is 50. Next I am taking cos 50t and I am differentiating e to the power of minus 40. So it is minus 4 e to the power of minus 40. So everything will be multiplied by 20. Okay, so now e to the power of minus 40 is common. So now I can take minus also common. So 20 is also common. So it is 50 sine 50t plus 4 cos 50t. So this is nano ampere. Next, 10 sine 20 pi t. So differentiating this with respect to t. In differentiation of sine is cos. This is constant. Cos 120 pi t. I cannot leave this as it is because t has a coefficient 120 pi, which is a constant. I am taking that outside. So it is 1200 pi cos 120 pi t and it is picocoulomb. Because of that I am converting it to picoampere. Okay. So next is 3 e to the power of minus t minus 5 e to the power of minus 2t. I can differentiate this with respect to t first. I am taking minus as it is. I am differentiating this with respect to t. I can do this, right? That is valid. So minus 3 e to the power of minus t minus 5 e to the power of minus 2t into minus 2. Minus 3 e to the power of minus t plus 10 e to the power of minus 2t nanoampere. So this is the answer. Okay, next you have to find the charge. Now you found the current by differentiating the charge. Now you can find the charge by integrating the current. So the reverse process of differentiation is integration. So now you have the initial charge also. So Q of t, that will give you integration of I of t dt, and you have to consider the initial charge. Okay, so here integration of 3 dt plus 1 coulomb. So it is 3t plus 1. What is the value? It is ampere. So it is coulomb. Okay. So next is 2t plus 5. So I have to integrate this. Okay. Plus 0 millicoulomb. It is milliampere. So I converted it to millicoulomb. 2. What is integration of this? Integration of constant is t. So it is t square plus 5t millicoulomb. Next, integration of 20 cos 10t plus pi by 6. Initial charge is 2. This is microcoulomb. This is also microcoulomb. 20 is constant as it is. Integration of cos is sine. Inner term I will write as it is. Since coefficient of t is 10, I am dividing it by 10, and this is 2. Whole thing microcoulomb. So this is the answer. Okay. So sorry, microcoulomb, correct. Next, integration of 10 e to the power of minus 30t sine 40t. Initial charge is 0. Since it is ampere, this is coulomb. 10 is constant, e to the power of minus 30t sine 40t. Now you have an exponential term. Now you have a trigonometric term. So this is of the form e to the power of my at sine bt dt. So we can write this as e to the power of at a square plus b square a sine b minus b cos b. Right? E to the power a sine bt b cos bt. So now I can write it as e to the power of minus 30. 900 plus 1600, it is 2500. A is minus 30. Comparing these two, sine of 40t minus 40 cos of 40t. So this I can simplify. Minus I can take outside. Minus and 10 also it is there, no? So 1 by minus 1 by 250 I can convert into decimals. Then I can write this as 30 sine 40t plus 40 cos 40t. So that will be the answer. Minus I have taken outside, so this will be plus. Okay. So this is all about the exercise 1.1, 1.2, 1.3.